First of all, I'd like to thank the organizers who have been incredibly helpful in trying to get me here. So we're going to start with the top-down approach. We're going to give some definitions, define some problems, and then try and find some solutions to these problems, more or less. And then we're going to see how the approach arising from trying to solve the problems, what happens when we try and apply it to empirical data. A word of note, I have no formal mathematical training whatsoever. I had just happened to stumble onto some mathematical looking concepts. I'm sure many of you can help me in this. So I define consciousness as subjective qualitative experience, say the taste of an apple or something of that sort. What it is like to be you in a specific state. Say you're experiencing your friend smiling at a joke that you just made. Something like that. And there's some properties that are of interest for this talk. One, that it is inherently dynamic, like the brain. We can quote William James' stream of consciousness. And this is particular because it's like temporally binded, it's smooth. We always continue to exist across time in some sort of sense. And these dynamics are quite special, and often in my field and in this conference, people focus on the fact that experiences tend to be repeated, and also brain states. They talk of brain states, modes, attractors. We talk about CDs as a metaphor and such things. But I would like to focus on the fact that, in another sense, experiences are never really repeatable. And so the brain, and this is derivable logically, and William James says it perfectly when he says, every brain state is partly determined by the nature of its entire past succession. It is out of the question, then any total brain state should identically reoccur. The same goes for experience rather than the brain, and try and give you further intuition. Bertrand Russell, in trying to distinguish live and dead things, notices that dead things always behave the same way in the same environment. Things that are alive do not. They change their behavior. So consider this. I somehow magically managed to control every physiological parameter in your body, and I make them perfectly identical in two different time points. I put you in an identical environment, give you an identical stimuli, and yet the two experiences would be different because you'd be recognizing the first experience. What's more, you'd probably feel very freaked out. But anyway, did we? Okay. Forget about the moving brain. So another aspect of consciousness is that it's intrinsic, and this is quite problematic. The fact that it's intrinsic derives from its definition. Being subjective experience, it is inherently part of the subject. You can only access your own experience from a first-person point of view. In fact, the definition, what it is like, which is our best definition, shows this problematic nature. What is it like to taste chicken? It is like tasting turkey. You can only understand experiences in reference to your own other experiences. I can only imagine about your experiences using my own experiences. And this brings many big problems for consciousness science, some fundamental, which we shall leave aside. I'm going to focus on the problems of comparing different consciousnesses and given the intrinsic nature of consciousness. And we shall start with a dramatic phrase, again by William James: absolute insulation, irreducible pluralism is the law. Now, let's leave aside the existential dread till when we have more wine. But the matter of fact, how do I compare a quality to another quality? If the experience is intrinsically mine, how can I evaluate it extrinsically? And I've been trying to find even thought experiments for it, and one of the best is given actually by Kate Bush. If I only could, I'd make a deal with God and get him to swap our places. The problem is that once I get your place, I could only evaluate my experience through your perspective. I wouldn't have my perspective anymore. And therefore it's problematic. But given, other than I can only know that I exist through my experience and we could be in a matrix and all those other problems that arise from this problem, there's also a very interesting paradox that arises that so we could have two different individuals who have very similar brain activations, but underlie different experiences. and that is because their brain activations refer to a different intrinsic context. Similarly, this is sort of a logical derivation from the intrinsic nature of experience. Different activities might underlie more similar experiences, and that is because, again, they refer to different internal contexts. As for mapping the subjective onto objective dynamics, we shall talk about that at a later stage in this talk. So I'm a neuroscientist of consciousness, and what we do in the neuroscience of consciousness is we get loads of brain states across different individuals and different states of consciousness. We put them all together in a massive pool, and from this pool we try and get some average states, or some centroids, or some components, depending on your algorithm. And through these average states, this sort of third space I create, I can compare different individuals and different states of consciousness. On the right here we have a very famous example of this, and it's a very popular method. But of course this denatures consciousness. First of all, there's no temporal continuity, but second of all, I'm creating averages that don't really exist and don't refer to the individual, which is fundamental for any experience, right? So I come up with this sort of very simple solution, and many people have sort of stumbled upon this, and the solution comes from the intuition that the subjective meaningfulness of your present is derived from its situation within its own past and its own future. So what do? We get a present state, maybe experiential, brain state, measured in different ways, and we see how it relates to its own past and its own future. And we do this recursively for every state. And what we get out of this is sort of this intrinsically defined dynamic space, a state space, if you will. And in this space, each state has a position defined by its relationship or distance between all its other states in the past and the future. And so it looks like this colorful thing here, where each column is a specific state, and all the values represent its distance or similarity to all the other states. And here we can reduce this high-dimensional space into this two-dimensional thing, and we can see an individual moving through their space of possible states, so to speak. The brighter colors, the hotter colors being later in time. Of course, this is in fact inspired by several theories. First and foremost, information integration theory, or integration information theory, I never remember which one it is, but which of course starts from the intrinsic nature of consciousness, which we talked about, but also defines information in terms of a cause-and-effect repertoire, which is the probabilities of your past and future states given your present. Of course, defining probabilities is very highly problematic, and I just have empirical data, so, but nonetheless, it's quite related in my opinion. Of course, there's a predictive coding account of consciousness, which says that what's important for consciousness is that we are able to model ourselves within our own past and our own future. Of course, that doesn't relate very much to this approach, only in as much that the relationship between the past and the future and the present is important. Then the temporal spatial theory of consciousness does what it says on the tin. Temporal spatial intrinsic spaces created by the brain are important for consciousness. And perhaps supporting the statement that we can never repeat brain states or experiences, the maximum similarity I find in all of the individual specific states is an R of 0.37. This excluding the autocorrelation, which is always very high. And I should test this on a better data set when and if I get to it. And so how do we compare different individuals? We just get these intrinsically defined state spaces, we look at those properties, and we compare those properties across individual without having to create a third average common space through which to compare different brains and different experiences. And so quickly I looked for properties of this space that scaled with different levels of consciousness. These levels of consciousness defined in a clinical manner. We can talk about it if you want, it's quite interesting. And I look at two principal elements, the short-term dynamics, the local transitions in time, which are represented by the value along the diagonal, and the more longer-term dynamics with the off-diagonal value. And we find several things, some more interesting than others. First of all, that in the short-term transitions, there's like consciousness tends to have bigger jumps over time. There's more distance percurred over time, basically meaning that conscious brains tend to be faster. But more interestingly is that the fact that this speed has much less variation in consciousness. And that means essentially that the brains tend to accelerate and deaccelerate less in consciousness. This is interesting for several reasons. First of all, consciousness is usually associated with complexity, but less variation indicates less complexity. And of course, you can't always just be more and more complex. There has to be some organization involved for consciousness. It just can't be more and more random and unpredictable. Another interesting thing is that perhaps this cruising speed, this smoothness of the speed, has something to do with the temporal binding, the continuity within our conscious experience. And furthermore, which is very testable, we can ask, well, perhaps subjective experiences say, if you're bored, your brain slows down. If you listen to some heavy metal, your brain speeds up. And this is quite testable, say manic versus depression within the same individual with bipolar. And Deanna and I actually came up with, I think, 7 or 8 experiments to test this. But then confirming our intuition about the complexity of consciousness, if you measure complexity in terms of unpredictability and or compressibility, then of course both the short-term and the long-term transitions are more complex. And now, how do we use this to map subjective onto neural dynamics? And the intuition is, again, very simple. So you have 2 experiences. The difference between the experiences should be proportional to the difference between the underlying brain states. Say I experience a light red and a dark red, and I experience a light red and a dark red. The distance between those brain states should be smaller than if I experienced a blue and a red, sort of to give you an intuition. So what do? We put individuals who are listening to a story in a brain scanner, and sadly other individuals who rate their subjective experience at the same temporal frequency of the scanner sampling. And so we have this subjective data over time, neural data over the time, and with the subjective data we just do what we did with the neural data prior, i.e. we get a specific moment in time and see how it relates to its own past and its own future. And therefore we put the subjective dynamics and the neural dynamics in the same space, and they can be directly compared. I found also Chalmers proposes a very similar solution when he describes the hard problem of consciousness at the end of his paper, in a much more abstract fashion though. And yeah, we need to control for autocorrelation, which is always there and will always boost, basically create false positives. But if we do that, it seems that we can map subjective onto objective dynamics in this way. We can take this a step further because we know that some of the neural dynamics now are related to the subjective dynamics, and we can directly compare the dynamics of different individuals. So we can ask, in consciousness, where in the brain are we more similar when we experience something, and where in the brain are we more different? Perhaps trying to elucidate the comparability of our experiences and the special parts of our experiences. And this is quite, the results are quite obvious. The most complex parts of the brain, the default mode network, which are further removed from the sensory inputs of the cortexes, in strong quotation marks. Those underline the more special dynamics. I should say, these are dynamics, I look at how similar you are to other people in consciousness compared to unconsciousness. Unconsciousness being a control condition here. But yeah, conversely, in the more simple parts of the cortex, our experiences become more similar when we experience the same thing. In the complex parts of the cortex, they become more different when we experience the same thing compared to unconsciousness. Now I'm going to be very cheeky and I'm going to ask you a question. With this method, we can we can put the whole brain and the parts of the brain in the same space and compare them. And this will sound familiar to a lot of you. And I know this is not a brilliant way, it's not an ideal way to test these theories, but this is not an ideal field. But so imagining this state space is a kind of information measure. We know that information integration theory, okay, I've got loads of time. Information integration theory, so yeah, although it's not the formal definition of information integration theory basically says information is more irreducible between the whole and the parts. So therefore, if we put the whole and the parts in the same space, they should be more different in consciousness. Conversely, global neuronal workspace says that information is propagated, broadcasted globally across the brain. Therefore, the whole and the parts should be more similar in consciousness compared to unconsciousness. And so my question to you is, to what extent, I know it's not ideal, but to what extent do you think this is a valid way to compare the two different theories? And please leave comments in the comment section below. Yeah, well, some future avenues that are afforded by this approach I find quite exciting. We can put all sorts of data in the same space as long as we can sort of find a common temporal axes. And that can be even done by downsampling and stuff like that. So all of a sudden we can like compare skin conductance to brain, to subjective measures, to pupillometry, all sorts of things. And we can start to see where the unique correlations and variations between all these types of measures are, and start to triangulate in a more holistic manner how all of these different parts of a human may relate to one another. Of course, this technique can be applied to, I just said this, to all sorts of different measures, and very cheaply, and perhaps that could be an exciting and perhaps even useful avenue, dare I say it. We can, this approach is half inspired by representational similarity analysis, I should say, and therefore we can easily compare different species as well as diseases and populations and things like that with this method, which is quite exciting. And this is also very exciting, and this was also, again, partly inspired by Deanne, but we can start to get accelerations towards specific states. And therefore we can start to get dynamical systems characterizations of specific states of consciousness, such as the more you accelerate, the more it's an attractor sort of thing. The longer you accelerate for, the wider the basin of these states. The problem is, how do we define specific states given the non-repeatable nature of experience? And the brain is inherently problematic of how to define it. You could probably combine the different approaches to try and sort this out. Of course, this was the data was collected in collaboration. I've had lots of interesting conversations about this throughout the years, and I have lots of people to thank, and probably this slide does not do justice on it. And thank you for listening. I look forward to conversations and questions, and